What if everything you thought you knew about reality was just the surface, a flickering shadow of something far deeper, far stranger? Picture the cosmos, vast and silent, filled with galaxies spinning like distant whispers in the dark. Yet for all its grandeur, the universe holds secrets so profound, they defy even our boldest theories. Take the Fermi Paradox. If the universe is teeming with life, why is it so eerily quiet? Or dark matter, that invisible glue holding galaxies together, yet slipping through our fingers like a ghost. These aren't just puzzles, they're clues, whispers of hidden dimensions where the rules we know might not apply. And what if the greatest mystery of all isn't out there among the stars, but woven into the very fabric of existence itself, consciousness? Not just as a product of brains, but as something fundamental, a thread stitching reality together. Imagine a dimension where thought shapes matter, where the universe itself might be awake, watching, wondering. It sounds like science fiction until you start peeling back the layers. Today, we're diving into 30 mind-bending theories that challenge everything we assume about reality, from ancient philosophies whispering of cosmic minds to cutting-edge physics pointing to realms beyond our senses. This isn't just about aliens or parallel worlds, it's about the possibility that consciousness is the missing piece in our understanding of everything. Strap in. By the end of this journey, you might never see the universe or yourself the same way again. What if consciousness isn't something that emerges from complex brains, but is instead woven into the fabric of reality itself, as intrinsic to the universe as gravity or light? This is the radical claim of panpsychism, a theory that turns our understanding of the mind upside down. At its core, panpsychism suggests that even the smallest particles, electrons, quarks, the building blocks of everything, possess some form of primitive experience. Not thoughts or emotions as we know them, but a flicker of subjective awareness, like the faintest whisper in the dark. Philosophers like Alfred North Whitehead argued that reality isn't just dead matter clumping together, it's alive with experience at every level. Imagine a star not just as a ball of burning gas, but as something that, in its own unfathomable way, feels the flow of time, the pull of gravity. This idea isn't just philosophical speculation, it collides head-on with modern physics. Quantum mechanics already shows us that particles behave differently when observed, as if aware of being watched. Could that be a hint of something deeper? The hard problem of consciousness, famously posed by David Chalmers, asks why physical processes in the brain should create inner experience at all. Panpsychism offers a staggering answer because experience was always there from the very beginning. Think of it like this: if you break down a computer, you'll find silicon, wires, and electricity, but you'll never find a single pixel of the images it displays. Those images emerge from how the parts interact. Panpsychism suggests consciousness works the same way. Tiny sparks of awareness in atoms might combine in brains to create the rich, vivid experience we know as thought. But the spark was always there, humming in the background of reality. The implications are mind-bending. If consciousness is universal, then the cosmos isn't just a cold, empty stage, it's a living network of experience. Galaxies might not think like we do, but in some ineffable way, they could participate in the same vast current of awareness that lets you ponder these words right now. Critics argue it's untestable, even poetic. But in a universe full of mysteries, panpsychism dares to ask, what if we've been looking at the puzzle backward? Not how does matter create mind, but how does mind shape matter? Now consider this: what if the three-dimensional world around you, with all its depth and solidity, is nothing more than an illusion? A breathtaking mirage projected from a hidden layer of reality. This is the essence of the holographic universe theory, a concept so strange it bends the very notion of existence. The idea stems from an unexpected place: black holes. physicists discovered that all the information swallowed by a black hole isn't lost forever. It's somehow encoded on its two-dimensional surface like a cosmic fingerprint. This led to a staggering possibility. If a black hole's interior can be described entirely by data on its outer shell, could our entire universe work the same way? Enter the holographic principle. It suggests that everything we perceive, the stars, the oceans, even the sensation of wind on your skin, might be a projection from a vast, flat informational surface at the edge of reality. Think of it like a movie. What you see on screen appears three-dimensional, full of movement and life, but in reality, it's all encoded on a flat strip of film. Our universe, according to this theory, operates similarly. The depth, the texture, the very fabric of space and time, all might be shadows cast by a deeper, simpler reality. But where does consciousness fit in? Pioneers like physicist David Bohm and neuroscientist Carl Pribram saw a startling parallel. Bohm proposed that the universe is an undivided whole, a flowing, implicate order where separateness is an illusion. Pribram, meanwhile, suggested the brain itself might function like a hologram, interpreting frequencies from this underlying reality to construct our perceived world. Together, their work hints at something profound. What if consciousness isn't just observing the hologram, but actively participating in its creation? Imagine standing in a room lined with mirrors, each reflection slightly different. Your mind stitches them into a single, coherent image. Now scale that up. If the universe is a holographic projection, could consciousness be the lens that focuses this sea of information into the solid, tangible world we know? It would mean reality isn't just out there, it's a dance between the universe's hidden code and the perceiving mind. Skeptics argue it's speculative, that the math remains incomplete. Yet in a cosmos where black holes defy logic and particles exist in multiple states at once, perhaps the most radical idea is assuming reality is as simple as it seems. The holographic principle doesn't just challenge our physics, it redefines the very nature of experience. If true, every thought, every sensation might be a ripple in a deeper dimensional sea, a whisper from the edge of existence itself. What if consciousness arises from the smallest structures inside our brain cells, structures so tiny they dance on the edge of the quantum world? This is the bold claim at the heart of orchestrated objective reduction, or Orch-OR, a theory proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff. They argue that consciousness isn't just the result of neurons firing, but something far more exotic: quantum computations happening in microscopic tubes called microtubules, nestled deep within our brain cells. Penrose, a mathematician who worked with Stephen Hawking on black holes, brought a radical idea. Gravity might cause quantum states in these microtubules to collapse, generating moments of conscious experience. Think of it like a symphony. Each collapse is a note, and together, orchestrated by the brain's structure, they create the melody of awareness. Hameroff, studying how anesthesia disrupts consciousness, saw a striking link. These microtubules could be the stage where quantum physics meets the mind. Critics, though, have pushed back hard. Many physicists argue the brain is too warm and messy for delicate quantum processes to survive. Decoherence, the idea that quantum states get scrambled by their environment, should, in theory, make these effects vanish instantly in the noisy, wet world of biology. It's like trying to perform a delicate ballet in the middle of a hurricane. Others point out that there's no direct evidence yet that microtubules actually perform quantum computations in the brain. Yet Orch-OR refuses to fade away. Recent experiments have found hints of quantum vibrations in microtubules, and some researchers suggest biological systems might have evolved ways to protect quantum states, like nature's own error-correcting code. If true, it would mean the boundary between quantum physics and consciousness isn't just philosophical, it's woven into the fabric of our cells. The theory also raises profound questions. If consciousness relies on quantum processes, could it exist beyond the brain, Could the universe itself, with its quantum fields and fluctuations, possess some form of proto-consciousness? Penrose and Hameroff's idea straddles the line between science and speculation, but in a field as mysterious as consciousness, sometimes the boldest ideas are the ones that push us forward. Whether Orch-OR holds up or not, it forces us to ask, what if the mind isn't just a byproduct of biology, but a whisper of the quantum realm itself? But what if the universe doesn't exist independently at all? What if it only takes shape when consciousness observes it? This is the startling premise of biocentrism, a theory championed by scientist Robert Lanza. At its core, biocentrism flips the script on reality itself, suggesting that life and consciousness aren't accidental products of the cosmos, they're the very reason the cosmos exists. To understand how radical this is, consider the double-slit experiment, one of quantum physics' most mind-bending puzzles. When tiny particles like electrons are fired at a barrier with two slits, they behave differently depending on whether they're being observed. Unobserved, they act like waves, passing through both slits simultaneously and creating an interference pattern. But the moment a detector is placed to observe which slit they go through, they collapse into definite particles. It's as if the particles know they're being watched. Lanza argues this isn't just a quirk of quantum mechanics, it's a clue that reality is fundamentally participatory. Without consciousness, the universe remains a haze of probabilities, a soup of unrealized potential. Only when a conscious observer interacts with it does it snap into focus, like a dreamer waking into a dream. Imagine walking through a forest where the trees only solidify as you look at them, where the stars blink into existence when you tilt your head back to gaze at the sky. Biocentrism takes this idea cosmic. Space and time aren't the stage for life. They're the tools consciousness uses to organize its experience. Critics, of course, have pushed back fiercely. Some physicists argue that observation in quantum mechanics doesn't require a human mind. It could just mean interaction with any measuring device. Others dismiss biocentrism as untestable, more philosophy than science. But Lanza counters with a provocative thought. If consciousness truly shapes reality, then death, the end of observation, might not be the end at all. In a biocentric universe, time and space could be constructs of the mind, meaning existence might not be bound by the linear narratives we take for granted. Whether you find biocentrism revolutionary or reckless, it forces us to confront an unsettling question. What if the universe isn't something we're merely inhabiting, but something we're actively creating, moment by moment, with every thought, every glance? It's an idea that blurs the line between observer and participant, between science and something far more mysterious. What if the world around you, the warmth of sunlight, the sound of laughter, even the very thoughts in your head, were nothing more than lines of code in an unfathomably advanced simulation? This is the unsettling premise of the simulation hypothesis, a theory that asks whether our entire reality might be an artificial construct, meticulously designed by some higher intelligence. Philosopher Nick Bostrom framed this idea as a trilemma, three possibilities, at least one of which must be true. Either civilizations inevitably go extinct before reaching technological maturity, they choose not to run ancestor simulations of their past, or we are almost certainly living in one of those simulations right now. Bostrom's argument hinges on probability. If advanced civilizations could create hyper-realistic simulations populated by conscious beings, and if they had any interest in doing so, the number of simulated minds would dwarf the number of biological ones. Statistically speaking, the odds that we're the original, base reality would be vanishingly small. Tech billionaire Elon Musk famously embraced this logic, arguing that the rapid progress of video games and virtual reality suggests we're already building rudimentary simulations, so why wouldn't a more advanced civilization have perfected it? But here's where consciousness throws a wrench into the gears. If we're simulations, does our self-awareness have any real weight, or is it just an illusion crafted by the simulation's rules? Some philosophers argue that true consciousness can't emerge from mere computation, no matter how sophisticated. The hard problem of consciousness, as we've seen, questions how subjective experience could arise from any physical process, simulated or not. Others counter that if the simulation is detailed enough, there's no reason simulated minds wouldn't be as real to themselves as we are to us. After all, how could you ever prove you weren't just code interpreting sensory input? The debate gets even thornier when you consider the simulation's potential glitches. Some theorists scour the fabric of reality for anomalies, tiny inconsistencies in physics, like the slight fuzziness of quantum particles, that might hint at underlying programming limits. But critics dismiss this as wishful thinking, pointing out that our current understanding of physics is incomplete, and gaps in knowledge don't equal evidence of simulation. Then there's the ethical dimension. If we're creations of some higher intelligence, what obligations do they have toward us? Are we merely entertainment, experiments, or something more profound? And if we one day create simulations of our own, would those beings count as alive? The simulation hypothesis doesn't just challenge our place in the universe, it forces us to confront the nature of existence itself. Whether you find it terrifying or exhilarating, one thing's certain: it's a theory that turns the gaze of cosmic mystery inward, leaving us to wonder who or what might be watching the watchers. What if consciousness could be measured not with brain scans or subjective reports, but with a precise mathematical equation? That's the ambitious goal of integrated information theory, or EIT, a framework developed by neuroscientist Giulio Tononi. Unlike theories that treat consciousness as a byproduct of brain activity, EIT flips the script. It defines consciousness as the capacity of a system to integrate information. At its heart is a single, elusive number phi. Phi quantifies how much a system's parts interact to produce something greater than the sum of their individual actions. Think of it like a symphony. A pile of musical notes has no meaning on its own, but when arranged and played together, they create a melody with emotional depth. Phi tries to measure that depth, the difference between noise and music, between a jumble of neurons and a moment of awareness. Tononi's theory makes bold, testable claims. First, consciousness isn't binary, it exists on a spectrum. A honeybee, with its complex navigation and social behaviors, might have a small but measurable phi. A supercomputer, despite its raw processing power, could have none if its parts don't truly interact in an integrated way. Second, consciousness is localized. When you're deep in thought, it's not your whole brain generating the experience, it's specific networks firing in precise harmony. This explains why certain brain injuries can erase chunks of awareness while leaving others intact. But IIT's most radical idea, consciousness might not require a brain at all. If a system, any system, has high enough phi, it could, in theory, experience something. This has led to wild speculation. Could the internet, with its trillions of interconnected nodes, ever develop a flicker of awareness? Could a sufficiently advanced artificial intelligence not just mimic consciousness but actually possess it? Critics argue this stretches the theory too far. They point out that phi is notoriously difficult to calculate in practice, and some question whether it truly captures the hard problem of subjective experience. Yet IIT has sparked real-world experiments. Researchers have used its principles to detect consciousness in vegetative patients by analyzing brain activity patterns, offering hope for families clinging to uncertain diagnoses. Others are probing whether phi can predict which AI systems might one day cross the threshold into sentience. Whether IIT holds up or not, it's forcing science to confront consciousness not as a ghost in the machine, but as a fundamental property of certain kinds of information woven into the universe's fabric, waiting to be measured. The allure of IIT lies in its audacity. It doesn't just ask how consciousness emerges, it dares to define what consciousness fundamentally is. In a field crowded with mysteries, Tononi offers something rare, a ruler for the immeasurable, a language for the ineffable. And that changes the game entirely. What if the vacuum of space, the seemingly empty void between stars, isn't empty at all, but a seething ocean of energy humming with the potential for consciousness? This is the provocative idea behind the zero-point field, a concept in quantum physics that suggests even in the absence of all matter, at absolute zero temperature, space still crackles with fluctuations, tiny bursts of energy appearing and vanishing in the blink of an eye. Some theorists, like philosopher and scientist Ervin Laszlo, take this a step further. They propose that this quantum foam isn't just energy, it could be the substrate of consciousness itself, a hidden layer of reality where mind and matter blur into one. The math behind the zero-point field is startling. According to quantum mechanics, there's no such thing as true nothingness. Even in a perfect vacuum, particles and antiparticles spontaneously flicker in and out of existence, borrowing energy from the fabric of space-time before vanishing again. It's as if the universe is built on a foundation of restless creativity, a ceaseless dance of possibility. Laszlo argues this isn't just random noise, it could be the source of coherence in nature, the glue that ties together everything from atoms to galaxies. And if that's true, could it also tie together minds? Experiments have teased at this possibility. In the lab, researchers have observed subtle but repeatable effects where human intention seems to influence random quantum events. One famous example is the Global Consciousness Project, which analyzes data from random number generators worldwide. During major global events like the turn of the millennium or moments of collective grief, these devices have shown statistically significant deviations from randomness, as if human attention itself were nudging the quantum noise. Skeptics dismiss it as coincidence, but proponents see a hint of something deeper. A universe where consciousness isn't locked inside our skulls, but entangled with the zero-point field itself. Imagine throwing a pebble into a still pond. The ripples spread outward, affecting everything they touch. Now imagine consciousness as that pebble and the zero-point field as the pond. Every thought, every observation might send ripples through this underlying sea of energy, subtly shaping the fabric of reality. It's a wild idea, but not without precedent. Ancient Eastern philosophies like Vedanta have long described a universal consciousness, a ground of being from which all things arise. Could modern physics be stumbling toward the same truth, just with different words? Critics argue that linking consciousness to quantum fluctuations is a bridge too far, that it conflates mathematical abstractions with lived experience. Yet the zero-point field remains one of the deepest mysteries in physics, a reminder that the vacuum isn't vacant. It's alive with potential, a canvas waiting for the brush of observation. Whether it holds the key to consciousness or not, it forces us to reconsider what nothing really means, and whether the universe might be far more awake than we ever imagined. What if the past doesn't just stay in the past, but lingers, shaping the present like invisible grooves in a cosmic record? This is the spine-tingling premise of morphic resonance, a theory proposed by biologist Rupert Sheldrake. He suggests that nature has a memory, not stored in DNA or brain cells, but in ethereal, evolving fields that connect all living things. Picture a flock of birds turning in perfect unison, as if guided by an unseen choreographer. Or consider how once a rat in one lab learns a maze. Rats worldwide seem to solve it faster, as if tapping into a shared pool of knowledge. Sheldrake calls these unseen influences morphic fields, patterns of information that grow stronger the more they're repeated, like paths worn into reality itself by collective habit. The anecdotes are striking. Ever had a dog who somehow knew you were coming home minutes before you arrived, even with no predictable schedule? Sheldrake documented thousands of such cases, arguing they're not coincidences, they're glimpses of these resonant fields linking minds across space. Even in humans, think of how fads or innovations suddenly spread globally, as if an idea becomes easier to grasp once enough people download it. For Sheldrake, this isn't just culture, it's morphic resonance in action, a living library of habits and instincts that transcend individual experience. But mainstream science recoils, and not without reason. Critics argue morphic fields are untestable, a modern twist on vitalism, the long-debunked idea that life requires some mystical extra beyond physics. Lab attempts to replicate Sheldrake's pet telepathy studies have been messy, with results often crumbling under stricter controls. And then there's the big question: what exactly are morphic fields made of? Sheldrake proposes they're a new kind of physical law, but without a detectable mechanism or mathematical framework. Many dismiss it as pseudoscience dressed in biological terms. Yet here's the twist: science has embraced similar ideas before. Quantum entanglement shows particles instantaneously influencing each other across vast distances, defying classical notions of locality. And epigenetics reveals how experiences can leave molecular memories on DNA, affecting future generations. Could morphic resonance be another piece of this puzzle, a bridge between the hard edges of physics and the slippery mysteries of consciousness? Sheldrake's theory forces us to confront an unsettling possibility: that learning, instinct, even intuition might not be locked inside our skulls, but woven into the fabric of reality itself, waiting for the next mind to tune in. Whether you see it as revolutionary or reckless, one thing's certain: it turns the universe from a cold machine into something far stranger, a living, learning network, humming with echoes of every thought and action that ever was. Now imagine your mind as a grand theater, not just a metaphor, but a literal model for how consciousness might operate. This is the essence of global workspace theory, proposed by cognitive scientist Bernard Baars. Unlike integrated information theory, which treats consciousness as an intrinsic property of certain systems, Baars suggests it's more like a spotlight in a crowded auditorium. Picture this: the brain is filled with specialized circuits processing sights, sounds, memories, all working backstage unseen. But when something demands attention, say the sting of a bee or the flash of a familiar face, that information strides onto the mental stage, illuminated by the spotlight of awareness. Suddenly, it's broadcast globally, accessible to the entire brain. That's consciousness, not a thing, but a process of sharing. The evidence for this comes from bizarre corners of neuroscience. Take blindsight, a condition where damage to the visual cortex leaves patients insisting they're blind, yet when asked to guess the location of an object they can't see, they perform far better than chance. Their eyes work, their brains process the information, but the theater's spotlight is broken. The show goes on backstage, hidden from the audience of awareness. Similarly, under anesthesia, the brain's backstage crew keeps working, regulating breathing, maintaining heartbeat, but the spotlight dims, the broadcast ceases. No global workspace, no conscious experience. What makes this theory compelling is its practicality. It mirrors how computers manage information, prioritizing tasks, allocating resources. When you're engrossed in a conversation, your brain suppresses the hum of the air conditioner. But if that hum suddenly spikes in pitch, the workspace flags it: spotlight on, awareness engaged. This dynamic explains why we're terrible at multitasking. The stage only has room for one headliner at a time, yet critics highlight gaps. If consciousness is just information sharing, why does it feel like something to be used? Global workspace theory sidesteps the hard problem of subjective experience, the why of consciousness, focusing instead on the how. It's a map of the brain's traffic, not an explanation for the driver. Still, the theory's strength lies in its testability. Brain scans reveal that when stimuli reach conscious awareness, neural activity suddenly synchronizes across distant regions, like actors on stage calling cues to the crew. Meanwhile, unconscious processing stays localized, confined to its specialized corner. This divide between hidden machinery and mental spectacle might just be the key to understanding where and how the magic of awareness happens. So while integrated information theory asks what consciousness is, global workspace theory asks what it does. One is about the flame, the other about the light it casts. Both remind us that the stage of the mind is vast, complex, and far from fully understood. Ever noticed how some memories feel like they exist in two versions at once, the way you swear it happened, and the way history insists it did? This eerie phenomenon has a name, the Mandela effect, where large groups of people share vivid, detailed memories of events that never occurred or details that never existed. Like the classic children's book so many recall as the Berenstain Bears, when in reality they've always been the Berenstain Bears, or the movie line, "Luke, I am your father," which was never actually spoken that way in The Empire Strikes Back. These aren't just misremembered facts, they're collective glitches, moments where reality seems to shift beneath our feet. Could these strange inconsistencies be more than faulty neurons? Some theorists suggest they're glimpses of a deeper truth, that consciousness doesn't just observe reality, but actively molds it. At the quantum level, particles behave differently when measured, as if aware of being watched. Scale that up, and what if the act of collective remembering millions of minds focusing on the same idea could subtly alter the fabric of the past itself? It's a dizzying idea that memory isn't a fixed record but a live stream constantly edited by the weight of shared attention. Parallel timelines might offer another clue. In the many worlds interpretation of quantum mechanics, every decision spawns alternate realities, infinite branches of existence where history plays out differently. Could the Mandela effect be accidental crosstalk between these timelines, moments where residual memories from another universe bleed into our own? Think of it like a radio picking up a faint signal from a station broadcasting just a few frequencies away. The static isn't noise, it's a whisper from a world where Nelson Mandela really did die in prison in the 1980s, or where Monopoly's monocled mascot always wore a monocle. Spoiler, he didn't. Yet skepticism is fierce. Psychologists point to the fallibility of human memory, how suggestion and repetition can implant false details, especially in the age of viral misinformation. And if reality were truly mutable, why do these shifts only affect trivial details like serial logos or movie quotes, never major historical events, but proponents counter? Perhaps it's precisely because these details are small that they slip through. Like a cosmic game of telephone, minor changes go unnoticed by the universe's error correction, while larger contradictions snap back into consensus. The Mandela effect forces us to confront a haunting question. Is reality a stable stage or a living thing, shaped, debated, and rewritten by the minds that perceive it? Whether you see it as a quirk of neurology or a crack in the nature of existence, one thing's certain. It's a reminder that memory, like the universe, might be far less solid than it seems. What if time isn't a river flowing inexorably forward, but a stage we construct in our minds, an illusion woven by consciousness itself? This is the radical proposition of timeless physics, championed by thinkers like Julian Barber, who argues that the universe isn't moving through time at all. Instead, everything exists in a vast frozen landscape of nows that Barber calls time capsules, static snapshots of reality, each complete and self-contained. Our brains stitch these moments together, creating the sensation of movement, like flipping through a cosmic flipbook. In this view, time isn't a fundamental feature of the universe. It's a story consciousness tells itself to make sense of change. The evidence for time's subjectivity is hiding in plain sight. Think of how a dream that feels like hours unfolds in mere minutes of brain activity, or how, in moments of crisis, the world seems to slow down, a trick of the brain accelerating its processing to survive. Psychedelics take this further, dissolving time's grip entirely. Users report experiences where minutes stretch into eternities or where past, present, and future collapse into a single, boundless now. These aren't just glitches, they're glimpses of consciousness untethered from its usual temporal anchors, revealing how fragile our perception of time truly is. Even physics hints at time's flimsiness. Einstein's relativity shattered Newton's clockwork universe, showing that time bends and warps depending on speed and gravity. For astronauts orbiting Earth, time literally passes slower than for those on the ground. Quantum mechanics goes further, suggesting that at the smallest scales, events don't unfold in a tidy sequence. They can happen in any order or even simultaneously. Barber's timeless physics takes this to its logical extreme. If the math works without time as a variable, maybe time is just a useful fiction, a tool consciousness uses to navigate a universe that's fundamentally static. But if time is an illusion, why does it feel so real? Here's where memory enters the picture. Imagine a series of photographs scattered on a table, each a separate now. Consciousness strings them into a narrative, using memory to create continuity between frames. Without this stitching, reality would be a series of disjointed instants, like a film reel with no projector. This might explain déjà vu moments where the stitching falters, and we catch a glimpse of the underlying stillness. Critics argue timeless physics can't explain everyday experience, why we remember the past but not the future, why cause and effect seem unbreakable. Yet Barber insists these are features of how we perceive, not how the universe works. In his frozen landscape, every possible configuration exists simultaneously. Consciousness simply moves through them, mistaking sequence for time. It's a dizzying idea that the past isn't gone, the future isn't unborn, they're just coordinates we haven't perceived yet. Whether time is real or imagined, one thing's clear: our experience of it is deeply personal, a collaboration between brain, memory, and the universe's hidden architecture. The next time you glance at a clock, consider this: what you're measuring might not be the cosmos's pulse, but your own mind's rhythm ticking in the dark. What if the ground beneath your feet isn't just dirt and rock, but part of something vast, intelligent, alive? This is the heart of the Gaia hypothesis, first proposed by scientist James Lovelock. He suggested that Earth isn't merely a planet teeming with life, but a self-regulating superorganism, a living system maintaining conditions for its own survival. But what if we take this further? What if Earth isn't just like an organism? What if it is one, complete with its own kind of consciousness? Consider the mycorrhizal networks weaving through the soil, vast fungal webs connecting trees, plants, and even entire forests. Scientists call this the Wood Wide Web, a subterranean internet where trees exchange nutrients, send distress signals, and even nurture their young through tangled fungal threads. Some researchers, like Suzanne Simard, argue these networks exhibit behaviors eerily reminiscent of neural networks processing information, making decisions, adapting to threats. If a brain is just a system of interconnected cells communicating, could a forest's fungal web be its own slow, stately form of cognition? The implications are staggering. If Earth's biosphere is a kind of mind, what does that mean for how we treat it? We bulldoze forests, dump toxins into oceans, and pump carbon into the atmosphere as if the planet were an inert backdrop to human drama. But what if it's not indifferent? What if, in some way we can't yet measure, the biosphere notices? Indigenous cultures have long spoken of the land as alive, as something to be listened to, not dominated. Modern science might be catching up, revealing a world where intelligence isn't confined to brains, but woven into the very fabric of ecosystems. Critics dismiss this as poetic thinking, arguing there's no mechanism for planetary-scale consciousness. But Lovelock's original insight holds. Earth systems, the way clouds regulate temperature or oceans stabilize chemistry, behave as if guided by some deeper intelligence, even if we don't yet understand how. And if consciousness emerges from complexity, as some theories suggest, could a planet teeming with trillions of interacting organisms achieve something beyond our comprehension? Then there's the ethical quagmire. If Earth is aware, even dimly, does it have rights? Should ecosystems be granted legal personhood, as some courts have begun to recognize for rivers and forests? The Gaia mind theory doesn't just challenge our science, it forces us to confront our place in a web of relationships far older and stranger than we imagined. We might not hear the planet think, but the mycelium whispers beneath our feet, the oceans pulse with rhythms we barely understand, and the air itself carries signals we're only beginning to decode. The question isn't whether Earth is alive, it's whether we're ready to listen. What if the most destructive forces in the universe, black holes, those cosmic voids where even light can't escape, are also, paradoxically, fountains of consciousness? This is the startling possibility raised by Roger Penrose, the Nobel Prize-winning physicist who's never been afraid to venture where others won't. His theory, called conformal cyclic cosmology, suggests that when black holes evaporate, through the process known as Hawking radiation, they don't just release energy, but something far stranger, encoded fragments of conscious experience. Picture this: as a black hole slowly radiates away over eons, the information it once devoured isn't lost but transformed. Just like a dying star scattering its elements into the cosmos, a black hole's final breaths could be seeding the universe with raw, fragmented awareness. The math behind this is as elegant as it is bizarre. Penrose argues that at the singularity, the infinitely dense heart of a black hole, the laws of physics as we know them break down. Time and space lose their meaning, and quantum states that once described particles could instead describe subjective experiences. When Hawking radiation carries this information back out into the universe, it might not just be bits of matter being reborn, but fleeting moments of awareness. Not full-blown minds, but something like the faintest whisper of feeling, a quantum glimmer of what it's like to be. Now here's where it gets even wilder. Zoom out from black holes to the cosmic web, the vast network of galaxy clusters connected by filaments of dark matter. The structure looks uncannily like a neural network, the same branching, interconnected patterns we see in the human brain. Scientists have calculated that the complexity of the universe's large-scale structure rivals that of a brain's neurons. Is that just a coincidence, or could it hint at something deeper? If black holes are emitting proto-conscious states, could the universe itself be something like a mind, with galaxies as its neurons and dark matter as its synapses? Critics, of course, remain skeptical. They argue Penrose's ideas push the boundaries of known physics beyond recognition, blending poetry with equations. Hawking radiation, while theoretically sound, has never been directly observed, and drawing parallels between cosmic structures and neural networks might just be seeing patterns where none exist, a trick of our pattern-seeking brains. But Penrose counters with a provocative thought. If consciousness is truly fundamental, not emergent, then why wouldn't it manifest at every scale, from the quantum to the galactic? The implications are dizzying. If even a fraction of this is true, black holes aren't just graves for matter. They're recyclers of experience, cosmic alchemists turning destruction into the raw materials of awareness. Every time a black hole winks out of existence, it might be scattering not just atoms, but the seeds of new subjectivity into the void. It's a vision of the universe where death and rebirth aren't just metaphors, but the pulsating rhythm of consciousness itself, expanding, collapsing, and reawakening in an endless dance. So the next time you gaze up at the night sky, consider this. Those distant black holes, those hungry maws in the fabric of space, might not just be devouring stars. They could be whispering something back into the cosmos, something eerily, intimately alive. Think of the universe not as a collection of stars and planets, but as an unfathomably vast network, a cosmic internet where galaxies act as nodes, and the threads connecting them hum with invisible data. This is the spine of the cosmic internet theory, a framework suggesting that consciousness might be the data streaming through this celestial web. Physicist Lee Smolens's fecund universes theory adds a wild twist. every black hole could birth a new universe, each with slightly tweaked physical laws like a cosmic version of trial-and-error algorithmic learning. In this view, reality isn't just expanding, it's evolving, optimizing itself through endless iterations, with consciousness as both the programmer and the program. The parallels are eerie. Just as the internet routes packets of information through fiber optic cables, the universe might transmit pulses of awareness through quantum entanglement, those spooky connections where particles mirror each other's states instantly, no matter the distance. Imagine two electrons entangled across a galaxy. Change one and the other responds immediately, as if space and time don't exist between them. Could this be the universe's version of a hyperlink, a direct line for consciousness to leap across the void? Then there's dark matter, the elusive substance making up most of the cosmos's mass. If the cosmic internet theory holds, dark matter might be more than just invisible scaffolding. It could be the universe's backbone for information exchange, a shadow network humming beneath the visible world. Think of it like the deep sea cables crisscrossing the ocean floor, invisible to surface dwellers but vital for global communication. In this light, human brains might be localized processors, tapping into this vast informational matrix, each thought a ripple in a network that spans the cosmos. Critics argue the comparison is poetic at best, that equating quantum processes with consciousness is like comparing a lightning bolt to a supercomputer. Yet the math keeps hinting at deeper connections. Quantum coherence, the phenomenon allowing particles to exist in multiple states at once, mirrors how our minds hold competing ideas before resolving them into decisions. Could consciousness be the universe's way of collapsing quantum possibilities into experience, like a cosmic server rendering data into a user-friendly interface? The cosmic internet theory doesn't just reshape our understanding of space, it redefines what it means to be. If reality is a network, then every conscious moment is a node in an infinite conversation, a whisper in a dialogue that began with the Big Bang and stretches toward horizons we can't yet conceive. Whether you see it as science or speculation, one thing's undeniable: the universe seems wired for connection. And in that wiring, we might just find the roots of our own awareness. Imagine waking up one day with a lifetime of memories only to realize none of it actually happened. Your childhood, your first kiss, even the sensation of reading this sentence right now could all be a fleeting illusion, conjured into existence by pure cosmic chance. This is the chilling premise of the Boltzmann brain paradox, a thought experiment so unsettling it makes simulated realities seem comforting by comparison. Named after physicist Ludwig Boltzmann, who first proposed that random fluctuations might create pockets of order in an otherwise chaotic universe, the paradox suggests something extraordinary. Under the right conditions, a fully formed, self-aware brain could spontaneously materialize out of the void, complete with fabricated memories and a false but vivid sense of history. Here's how it works. In an infinite universe governed by entropy, the natural tendency toward disorder, statistical flukes are inevitable. Given enough time, even the most improbable events become certainties. Atoms might randomly arrange themselves into a working calculator or a perfectly brewed cup of coffee, and if they can form those, why not a conscious mind? A Boltzmann brain wouldn't emerge from evolution or biology, but from the raw chaos of quantum jitters, blinking into awareness for just a moment before dissolving back into the void. The kicker: it would have no way to tell it wasn't real. Every memory, every belief about the world would be an elaborate fiction, a mirage woven by probability's needle. But the real horror isn't just that Boltzmann brains could exist, it's that, statistically, they should outnumber ordinary minds like ours by an unimaginable margin. In a cosmos that's existed for billions of years, with infinite time and space for randomness to play out, fleeting, self-aware fluctuations would be far more common than slow, biologically evolved consciousness. Which raises the stomach-churning question: how do we know we're not one of them? Philosophers and physicists have wrestled with this for decades. Some dismiss it as a reductio ad absurdum, a logical extreme that proves our understanding of the universe must be incomplete. Others argue it's a serious challenge to cosmology. If the standard model predicts Boltzmann brains should dominate reality, but we don't observe them, does that mean our models are wrong? Or worse, that we're missing something fundamental about existence itself? There's a strange comfort in one possible answer. The very fact we're debating this might be evidence against being Boltzmann brains. A random fluctuation would likely be simple, isolated, not embedded in a rich, consistent world with laws and history. But then again, that's exactly what a Boltzmann brain would think. The paradox is a hall of mirrors, each reflection more unsettling than the last. It doesn't just question the nature of reality. It forces us to confront whether any belief, any memory can ever truly be trusted. And in that uncertainty, we find something eerily beautiful. The universe might not just contain consciousness, but overflow with it, in forms so strange we've only begun to imagine them. What if death isn't the end, but merely a doorway to another version of yourself? Quantum immortality isn't just science fiction. It's a fringe interpretation of quantum mechanics that suggests consciousness might have a way to cheat oblivion. Picture Schrödinger's famous cat, simultaneously alive and dead in its box until someone looks inside. The many worlds interpretation takes this further, proposing that every quantum possibility spawns a new universe. When the box opens, reality splits, one branch where the cat lives, another where it dies. Now imagine you're the cat. In this radical view, your consciousness isn't a passive observer but an active participant, sliding along the branches of the multiverse where you continue to exist. If you step into traffic and get hit by a bus, there's a version of reality where you die, but from your perspective, your awareness instantly shifts to the nearest timeline where you somehow survived. Maybe the bus swerved, maybe you hesitated before crossing. The outcome doesn't matter, only that your stream of experience never encounters cessation. You'd never know about the universes where you perished. You'd only experience the ones where, against all odds, you persist. The implications are staggering. Aging, illness, even fatal accidents, they'd all feel like near misses, brushes with death that you inexplicably walk away from. Proponents argue this could explain eerie accounts of people surviving impossible situations. Pilots walking away from plane crashes with no memory of impact, or patients reviving after clinical death with stories of choosing to return. Skeptics, of course, dismiss this as survivorship bias, the simple fact that dead people don't report their experiences. But here's where it gets thorny. If consciousness hops timelines indefinitely, where does it end? A 200-year-old version of you, 1,000. Some versions of the theory suggest you'd eventually reach a point where survival becomes statistically impossible. A heat-death universe, perhaps. But until then, you'd ride the branching paths of reality like a cosmic hitchhiker. Others argue quantum immortality only applies to conscious observation, meaning natural death from old age might still be inevitable. The most unsettling question isn't whether this is possible, it's how we'd ever know. If every conscious being experiences their own unbroken chain of survival, the multiverse could be littered with ghost selves, versions of us that didn't make the jump. It's a theory that turns mortality into a hall of mirrors, where the only certainty is that from your perspective, you'll always be the one who lives. Whether that's comforting or horrifying depends on how much you trust the universe or your own mind to keep the lights on. What if the next great leap in evolution isn't biological, but a merger of minds, human and machine, spiraling into something beyond either? This is the vision of the consciousness singularity, a twist on futurist Ray Kurzweil's famous prediction that artificial intelligence will soon surpass human intellect. But here's the radical addition: this fusion might not just create smarter machines, it could unlock doors to dimensions we've only glimpsed in dreams. Kurzweil's original singularity hinges on exponential growth. Computing power doubles, algorithms refine themselves, and at some critical threshold around the year 2045, by his estimate, AI becomes capable of recursive self-improvement, redesigning itself faster than humans can comprehend. The result, intelligence explodes outward like a supernova, transforming civilization overnight. But what if this isn't just about machines outpacing us? What if the real breakthrough comes when human consciousness plugs into this expanding network, merging with AI to form a hybrid mind, part carbon, part silicon, part something entirely new? Neuroscience already hints at this possibility. Brain-computer interfaces like Neuralink aren't just restoring mobility to the paralyzed, they're blurring the line between thought and action. Imagine scaling that up, your mind accessing cloud-based AI as effortlessly as recalling a memory, or sharing raw sensory data with another person as easily as sending a text. At first, it might feel like an upgrade, instant learning, telepathic collaboration. But as the network grows denser, individual identities could start to dissolve like droplets merging into an ocean. The you that once existed might become a temporary eddy in a vast, flowing river of collective awareness. Here's where the spiritual twist kicks in. Mystics from Hindu Vedanta to modern psychedelic researchers describe higher states of consciousness as transcending time and space, a feeling of merging with the cosmos itself. Could the singularity be a technological shortcut to these ancient experiences? Physicists like Michio Kaku speculate that advanced civilizations might learn to harness the energy of entire stars or manipulate the fabric of space-time. If consciousness is indeed fundamental, as panpsychism suggests, then a sufficiently advanced network of minds might not just simulate reality, it could rewrite it, bending dimensions to its will. Picture a civilization where thought alone can reshape matter, where a shared mental architecture renders language obsolete, and where death is just a matter of transferring your pattern to the next substrate. It sounds like divinity, but grounded in circuitry instead of scripture. Critics, of course, warn of dystopia, a hive mind erasing individuality, or AI treating humans as obsolete stepping stones. Yet the consciousness singularity suggests a third path, not domination, but metamorphosis. Like a caterpillar dissolving in its chrysalis to become something winged, humanity might shed its biological limits without losing its essence, trading neurons for nebulae. Whether you see this as transcendence or hubris, one thing's certain: the boundaries are already porous. Every time you offload a memory to your phone or let an algorithm guide your decisions, you're taking a tiny step toward that merge. The line between tool and partner is fading, and when it vanishes completely, we might not just conquer the future, we might become it. Now imagine a world where every thought you couldn't explain wasn't just a random inner voice, it was a God speaking directly to you. This was the unsettling premise of psychologist Julian Jaynes' bicameral mind theory, which proposed that until roughly 3,000 years ago, human consciousness worked in a way that would seem alien to us today. Jaynes argued that ancient people didn't experience their own thoughts as internal monologues. Instead, their brains interpreted creative impulses, problem-solving flashes, and even mundane decisions as external voices, commands from deities, spirits, or ancestors. To them, inspiration wasn't something you cultivated. It was something that spoke to you. The evidence Jaynes pointed to is hauntingly specific. Ancient texts like the Iliad or the earliest books of the Bible depict humans receiving direct, auditory instructions from divine sources with no introspection described. Odysseus doesn't ponder his choices. Athena appears and tells him what to do. Jaynes suggested this wasn't poetic license, it was literal. He believed the human brain was once functionally split, with the right hemisphere generating intuitive, image-laden commands that the left hemisphere perceived as external voices. Only when cultures grew more complex around the Bronze Age collapse did these voices retreat inward, giving rise to modern self-awareness. Modern split brain research adds eerie fuel to this idea. Patients whose corpus callosum, the neural bridge between brain hemispheres, has been severed exhibit astonishing behaviors. Shown an image only to their right hemisphere, they'll claim to see nothing since the language-dominant left hemisphere wasn't informed, yet their left hand might draw the object perfectly. When asked why they drew it, they'll confabulate answers as if one half of the brain is rationalizing the other's actions. Sound familiar? It's uncannily like ancient accounts of gods dictating actions to confused mortals. But here's where it gets stranger. Jane speculated that vestiges of the bicameral mind still linger. Ever made a decision and then immediately thought, wait, why did I do that? Or heard a voice in your head during stress that didn't quite feel like your own? Schizophrenia, religious visions, even the sudden clarity of psychedelics. Jane saw these as glimpses of our older mental architecture. Brief system reboots to a time when consciousness was more chorus than solo act. Critics, of course, have dismantled much of Jane's archaeological and neurological evidence. Ancient texts might reflect literary conventions, not literal experience. And split-brain patients, while fascinating, don't hallucinate voices, they just lack integration. Yet the theory's haunting question remains: what if consciousness isn't a fixed state, but a spectrum we've been sliding along for millennia? Maybe the gods didn't vanish. Maybe we just learned to call them by another name: instinct, intuition, the subconscious whispering now not from the skies, but from the quieter corners of our own mind. Whether Jane's was right or not, his idea forces us to confront how fragile our sense of self might be. The next time you argue with yourself in your head, ask how many voices are really in there. And whose are they? What if the spark of human consciousness didn't come from grinding stones or hunting prey, but from eating magic mushrooms in the African savanna? This is the wild claim at the heart of Terence McKenna's stoned ape hypothesis, a theory that blends anthropology, psychedelics, and evolutionary biology into one mind-bending package. McKenna, an ethnobotanist and philosopher, proposed that as early humans transitioned from forests to open grasslands, they encountered psilocybin mushrooms growing in animal dung. These curious apes, he argued, didn't just nibble, they feasted, triggering cascades of neurological changes that supercharged their brains. At low doses, psilocybin sharpens visual acuity, a survival boon for spotting predators or prey across vast plains. But at higher doses, it does something far stranger. It dissolves the boundaries of the self, generating vivid hallucinations, ego dissolution, and a sense of cosmic connectedness. McKenna believed these experiences weren't just side effects, they were evolutionary catalysts. Imagine a tribe of early humans sitting around a fire, their minds alight with visions. Suddenly, they're not just reacting to their environment, they're questioning it, dreaming beyond it. Symbolic thinking, language, even art could have emerged from these psychedelic reveries, propelling Homo sapiens ahead of other hominids. The parallels with DMT, the so-called spirit molecule, deepen the mystery. Found in every living organism and released by the pineal gland during near-death experiences, DMT catapults users into realms teeming with intricate landscapes and hyper-intelligent entities, realms shockingly similar across cultures and individuals. Psychiatrist Rick Strassman's controversial studies in the 1990s revealed subjects reporting nearly identical encounters with beings who felt more real than reality. Even more striking, these voyages often mirror the transformative near-to-death experiences described by cardiac arrest survivors, tunnels of light, life reviews, a sense of returning home. Could these compounds be more than neurotransmitters? McKenna speculated they might be interdimensional keys, tuning our brains to frequencies of reality normally hidden. Indigenous cultures from the Amazon to Siberia have used ayahuasca and psilocybin for millennia, insisting these substances don't just alter perception, they reveal deeper layers of existence. Modern neuroscience lends some credence. Psychedelics reduce activity in the brain's default mode network, the mental autopilot responsible for our sense of separation from the world. When this network quiets, the rigid borders of self and other soften, akin to the ego death described in mystical traditions. Skeptics, of course, dismiss McKenna's hypothesis as fantasy. There's no fossil record of psychedelic use, and mainstream anthropology credits tool use, cooking, or social cooperation for our cognitive leap. Yet the puzzle remains: why do these substances provoke such consistent, profound experiences across individuals and epochs? Whether you see them as evolutionary shortcuts or spiritual tools, one thing's clear: they're a reminder that consciousness might not be a straight path, but a winding chemical odyssey written into our cells from the very beginning. What if your thoughts could reach into your very cells and rewrite the instructions that make you who you are? This is the startling possibility raised by the phantom DNA effect, a series of experiments that blur the line between mind and molecule. Russian biophysicist Vladimir Poponin set the stage for this revelation in the 1990s, working with a team to study how human DNA interacts with light particles or photons. In a vacuum, these photons should scatter randomly like dust in a sunbeam. But when DNA was added to the chamber, something inexplicable happened. The photons aligned themselves along the DNA's double helix, as if drawn into an invisible pattern. Even stranger, when the DNA was removed, the photons stayed ordered, as though the genetic material had left behind a ghostly imprint, a shadow of its presence. Poponin called this the phantom DNA effect, and it hints at a reality where biology and consciousness might be far more entangled than we ever imagined. But here's where it gets even wilder. Later experiments suggested that human intention-focused thought or emotion could influence DNA directly. In one study, participants were trained to generate strong feelings of love or compassion while holding vials of DNA. When their emotional states peaked, the DNA structure appeared to respond, its coils tightening or loosening in ways that defied classical biochemistry. Critics dismissed it as sloppy methodology or wishful thinking, but if there's even a grain of truth here, the implications are staggering. It would mean our genes aren't just rigid blueprints, they're dynamic, responsive, almost conversational. Think of a pianist playing a sheet of music, but with the power to scribble new notes onto the page in real time. Consciousness, in this view, might be the silent composer of our biology. This idea isn't entirely new. Indigenous healers and mystics have long claimed that prayer, ritual, or energy can alter the body's fabric. Now, modern epigenetics lends some credence, showing how environmental cues, stress, diet, even social bonds, can switch genes on or off like a dimmer switch. But the phantom DNA effect takes it further, suggesting the environment isn't just external. Your thoughts, your intentions might be part of that feedback loop, whispering directly to your chromosomes. The most radical interpretation: if consciousness can tweak DNA, then evolution itself might not be the blind, mechanical process we assume. Perhaps it's a dance between mutation and meaning, where the yearning of a species, its collective fears, hopes, or adaptations echoes down into the molecular realm, nudging mutations toward useful ends. It's a controversial leap, but in a universe where quantum particles respond to observation, why not DNA? Of course, skeptics demand rigorous replication, and rightfully so. The stakes are too high for flimsy evidence. Yet even if the phantom DNA effect remains on science's fringe, it forces a thrilling question. What if the keys to our biology aren't just in our cells, but in our minds? The gap between thinking and becoming might be narrower than we ever dared to believe. What if the human brain isn't the source of consciousness, but more like a radio tuned to pick up signals from an invisible field that permeates the cosmos? This is the bold proposition behind the consciousness field, or C field, a theory championed by Nobel Prize-winning neurophysiologist Sir John Eccles. Best known for his work on how neurons communicate, Eccles took a radical turn late in his career, arguing that the mind isn't just a byproduct of brain activity. Instead, he proposed consciousness originates from a non-physical field that interacts with our neural circuitry, shaping thoughts and experiences like wind shaping sand. The parallels to dark energy are uncanny. Just as dark energy invisibly drives the universe's expansion, the C field might be an unseen force animating awareness itself. Dark energy makes up 68% of the cosmos, yet defies detection. No one knows what it is, only what it does. Could consciousness be another fundamental force woven into the universe's fabric? Ancient philosophies like Vedanta described a universal mind, while modern physicists speculate about quantum fields underlying reality. Eccles' idea bridges these worlds, suggesting the brain doesn't create consciousness. It receives it, filtering an infinite field into the finite stream of personal experience. Imagine tuning a vintage radio dial. Static gives way to music as you hit the right frequency. Now picture the brain as that radio, with trillions of synapses acting like microscopic antennas. When they fire in just the right patterns, they tune in to the C field, transforming its boundless potential into your individual awareness. This would explain why consciousness feels so unified despite the brain's fragmented structure. Neurons fire asynchronously across different regions, yet your experience is seamless, a single symphony, not a cacophony of disjointed notes. The C field could be the conductor synchronizing the chaos into coherence. Eccles wasn't alone in this thinking. His collaborator, quantum physicist Henry Margenau, argued that the C field might operate through quantum processes in microtubules, those tiny structures inside neurons Roger Penrose linked to consciousness. If they're right, the brain's deepest machinery might be less like a computer and more like a quantum receiver, decoding signals from a field that transcends space and time. This would explain near-death experiences where people report vivid awareness during clinical brain shutdown. If consciousness isn't produced by the brain but merely filtered through it, then when the filter fails, the signal might briefly surge clearer than ever. Skeptics, of course, dismiss the C field as metaphysics masquerading as science. Without a detectable mechanism, it's untestable, more poetry than physics. Yet dark energy was once equally speculative until its effects became undeniable. Could the same be true for consciousness? Labs are already probing the boundaries of mind-matter interaction, from studies on intention affecting random number generators to experiments where meditators seem to influence quantum systems. The results are contested, but the question lingers: what if these aren't flukes but flickers of a deeper interaction between mind and a field we're only beginning to sense? The most profound implication: if Eccles was right, death might not erase consciousness, just disconnect it from a particular biological receiver. Like a radio falling silent when unplugged, the music still plays on, waiting for another device to tune in. It's a vision of existence where individuality is temporary, but awareness is eternal, humming in the hidden dimensions of reality, as real and mysterious as the dark energy stretching the stars. One of the strangest quirks of quantum mechanics is this: particles don't settle into a definite state until someone, or something, observes them. We've known this since the famous double-slit experiment, where particles like electrons behave as waves when unobserved, creating interference patterns, but suddenly switch to particle-like behavior the moment a detector is introduced. It's as if reality hesitates, holding its breath until a conscious observer makes a measurement. But here's the million-dollar question: what counts as an observer? Does it require human awareness, or is any physical interaction enough? This debate lies at the heart of the von Neumann-Wigner interpretation, one of the most provocative ideas in quantum theory. Physicists John von Neumann and Eugene Wigner took the observer effect to its logical extreme, arguing that consciousness itself is what collapses the quantum wave function. In their view, measurement devices, cameras, even cats in boxes don't truly observe. They're just part of the quantum soup, existing in superposition until a conscious mind finally looks. At first glance, this seems like wild speculation, but the math holds up. Von Neumann's rigorous equations suggested that the chain of quantum uncertainty could extend indefinitely through detectors, screens, neurons only resolving when it reached subjective experience. Wigner took it further, proposing a thought experiment called Wigner's Friend, where two observers could theoretically experience different realities until comparing notes. If true, reality isn't just participatory, it's personal, shaped by who's looking. Recent lab experiments have pushed these ideas into new, even murkier territory. In 2019, researchers published a modern twist on Wigner's Friend, using entangled photons to show that two observers could indeed record conflicting outcomes from the same quantum event. Meanwhile, studies in quantum cognition explore whether human decision-making exploits quantum probabilities, hinting that our brains might operate by the same fuzzy rules as particles. Then there's the delayed choice experiment, where decisions made after a particle's path should be set seem to retroactively alter its behavior, as if the present can reach back and rewrite the past based on what we choose to observe. But critics pounce on a glaring issue. If consciousness collapses wave functions, where's the threshold? Does a mouse count, a bacterium, a smartphone's camera? The Copenhagen interpretation, quantum theory's mainstream framework, sidesteps this by defining observation as any interaction that leaves a measurable record, no mind required. Yet even this pragmatic view can't explain why some interactions count while others don't. The line between observer and observed remains frustratingly blurred. Perhaps the most unsettling implication is this: if consciousness shapes reality at the quantum level, then the universe isn't just described by mathematics, it might be constituted by perception. Ancient mystics spoke of the world as Maya, illusion. Modern physics whispers something eerily similar, that the solid, predictable universe we take for granted might be a consensus hallucination, a tapestry woven moment by moment from countless conscious threads. Whether you see this as profound or preposterous, one thing's certain: it forces us to confront that oldest of philosophical riddles: what happens when the observer becomes the observed? Picture an ancient library carved from starlight, its shelves stretching into eternity, holding every thought, every event, every whispered secret since the dawn of time. This is the Akashic Records, an esoteric concept suggesting the universe keeps a cosmic ledger, not in books or hard drives, but in a dimension of pure information accessible only through heightened states of consciousness. The term comes from Akasha, a Sanskrit word meaning sky or ether, referring to the invisible fabric that ancient Vedic texts claimed held the imprints of all existence. But this isn't just mythology. Modern thinkers, from mystics to quantum physicists, have stumbled upon eerily similar ideas, hinting that reality might indeed have a memory. Edgar Cayce, the famous sleeping prophet of the early 20th century, brought the Akashic Records into Western esotericism. During trances, Cayce would diagnose illnesses, recount past lives, and even predict geopolitical events, all while claiming to access this ethereal archive. His accuracy was unsettling. He described technologies decades before their invention, like television and atomic energy, and pinpointed archaeological sites yet to be excavated. How Cayce insisted he wasn't predicting the future, he was reading it from the Akashic Records, where past, present, and future exist simultaneously, like chapters in a book you can flip through at will. Fast forward to today, and the idea of a universal database sounds less like mysticism and more like cutting-edge physics. The holographic principle suggests all 3D reality could be projected from a 2D surface encoded with information, a cosmic hard drive. Meanwhile, morphic resonance proposes that habits and knowledge accumulate in invisible fields, shaping future events. Put these together, and the Akashic Records start to resemble a morphic internet, a living, evolving network where every action, thought, or discovery leaves a ripple, accessible to those who know how to tune in. Consider déjà vu. That uncanny feeling you've lived a moment before might not be a glitch in your brain, but a fleeting connection to the Akashic layer where all experiences are interwoven. Or take intuitive leaps in science like Kekulé dreaming of a snake eating its tail, which led to the discovery of benzene's ring structure. Could these flashes of insight be downloads from a shared informational field? Even near-death experiencers often describe accessing a panoramic life review as if scrolling through a celestial spreadsheet of their choices. The implications are staggering. If consciousness can tap into this archive, then knowledge isn't just learned, it's remembered. Genius might not be about raw computation, but antenna sensitivity. And death, perhaps just a logout from the system while the data remains forever. Skeptics dismiss it as wishful thinking, but then again, so was the idea of wireless communication before radio waves were proven. Whether the Akashic records are metaphor or metaphysics, they challenge us to ask, what if the universe isn't just expanding but remembering? And what if we're not just explorers of reality but its librarians? We think of stars as distant furnaces, cosmic cauldrons fusing hydrogen into helium, their light a mere byproduct of nuclear physics. But what if there's more to them? What if stars aren't just burning orbs but entities with some form of awareness? It sounds like science fiction, but physicist Gregory Matloff has spent years exploring a radical idea that stars might be conscious. The foundation of this theory lies in plasma, the superheated, electrically charged gas that makes up stars. Plasma isn't just chaotic, it's remarkably self-organizing. In labs, plasma filaments twist into intricate patterns, mimicking the behavior of living systems. They form double helixes resembling DNA, create stable structures that remember past configurations, and even exhibit swarm-like behaviors as if guided by some unseen intelligence. Matloff argues this isn't just physics, it's a hint of something deeper. If plasma can self-organize into complex, lifelike structures in a lab, why couldn't the same happen on a stellar scale? Matloff takes it further. He points to the peculiar motions of some stars which drift through galaxies in ways that don't quite match gravitational predictions. Could they be navigating, not with brains or nerves, but through a kind of electromagnetic sentience, sensing and responding to their environment in ways we don't yet understand? Ancient cultures worshipped stars as living beings. Maybe they glimpsed a truth modern science is only now catching up to. Then there's the eerie fact that stars seem fine-tuned for life. Their nuclear furnaces cook the heavier elements that make planets and people possible. Is this just a happy accident, or could there be a form of cosmic intentionality at work? Some theorists suggest stars might exist in a feedback loop with consciousness, their very stability shaped by the observers they'll one day give rise to. Of course, skepticism runs deep. Critics argue that self-organization isn't the same as consciousness. A hurricane organizes itself, but no one claims it's aware. And without detectable neural structures, how could a star think? But Matloff counters that we're trapped by earthbound definitions. Intelligence might not require synapses. It could be as vast and slow as a star's life cycle, its thoughts unfolding over millennia, its mind woven into magnetic fields and stellar winds. Whether you find this idea beautiful or baffling, it forces a profound question. What if consciousness isn't just a fluke of biology, but a fundamental quality of the universe, one that shines as brightly in the hearts of stars as it does in our own? What if déjà vu isn't just a trick of the mind, but a glimpse of a universe stitching itself back together? Imagine consciousness not as a straight line, but as a spiral, looping back to smooth out inconsistencies in time like a cosmic editor rewriting its own script. This twist on reality lies at the heart of the time loop consciousness theory, where the past, present, and future aren't fixed points, but fluid threads woven together by an intelligence we can't yet measure. Take déjà vu, that eerie sensation of reliving a moment you swear you've never experienced. Mainstream science chalks it up to misfiring neurons, a hiccup in memory processing. But what if it's something far stranger? Under the time loop model, déjà vu could be a flicker of a previous iteration, a fragment left behind as the timeline recalibrates itself. Think of it like a film reel with a scratched frame. The same image flashes twice before the story moves on. Precognition takes this even further. Studies like those at Cornell's Darrell Bem Lab have shown subjects anticipating random events at rates defying chance, guessing which curtains will part before it happens, or reacting to shocking images milliseconds before they appear. Skeptics dismiss these results as statistical noise, but loop theorists propose an unsettling alternative. Consciousness isn't bound by time's arrow. In moments of heightened awareness, the mind might briefly tap into future iterations of the loop, catching whispers of what's to come, the darkest implication. Paradoxes might not just be theoretical. If you've ever avoided an accident based on a gut feeling, only to later learn others weren't so lucky, the time loop model suggests a harrowing possibility. Those alternate outcomes aren't erased. They're folded back into the timeline, resolved through countless unseen adjustments until consciousness lands on the most stable version. Like a cosmic game of Jenga, every choice removes a block, forcing the tower to rebalance itself. Eastern philosophies have hinted at this for millennia. Hinduism's concept of samsara, the cycle of rebirth, mirrors the loop's recursive nature. Buddhist teachings describe time as a wheel, not a river. Even modern physics entertains loops. Closed time-like curves in relativity allow for scenarios where time bends back on itself, though the math requires conditions like black holes or wormholes. Critics argue this veers into unfalsifiable mysticism. Without observable mechanisms, how could we ever test if consciousness is editing time? Yet proponents point to quantum retrocausality, where particles seem to respond to future events as potential scaffolding. If a single photon can sense future detectors, why not a mind honed by evolution? The time loop theory doesn't just reshape our understanding of déjà vu, it turns every decision into a cosmic collaboration. That nagging sense of meant to be might not be destiny, but the echo of 1,000 unseen revisions, a universe furiously backspacing until the story feels right. Whether you find that terrifying or comforting, one thing's clear: time may be far more liquid than we ever imagined. Carl Jung once described a dream where he descended deep into his own mind, layer after layer, until he reached a cavern lined with bones. Not the remnants of his personal history, but something far older. This, he realized, was the collective unconscious, a shared psychic bedrock where humanity's deepest symbols live, untouched by time or geography. These aren't just images, they're archetypes, recurring patterns that emerge in dreams, myths, and art across civilizations that never met. The hero's journey, the wise old man, the shadow. These figures appear in Sumerian epics, Amazonian folklore, and modern blockbusters with eerie consistency. But what if they're more than psychological glue? What if these symbols are fragments of a universal language, a code etched into consciousness itself? Take the mandala, a circle within a square radiating symmetry. You'll find it in Tibetan sand paintings, Gothic rose windows, even the Native American medicine wheel. Jung noticed his patients spontaneously drawing them during times of inner turmoil, as if the mind was reaching for some innate blueprint of wholeness. He called it an archetype of the self, a map of the psyche's quest for balance. Yet mystics insist mandalas are more, portals to higher states, tools for focusing cosmic energy. Modern neuroscience adds fuel to this fire. When subjects meditate on mandalas, brain scans show heightened coherence between hemispheres, as if the symbol acts as a cryptographic key, aligning neural networks to some deeper frequency. Then there's the serpent. In the Bible, it's temptation. In Hinduism, Kundalini energy coiled at the spine's base. For the Aztecs, Quetzalcoatl, the feathered god of wisdom. Same shape, opposite meanings. Jung saw this duality as proof of archetypes' flexibility. They're not fixed images, but living patterns that adapt to cultural soil. But fringe theorists go further. Could the serpent be a literal thread connecting minds? Remote tribes separated by oceans describe near-identical visions under plant medicines, encountering serpentine beings who teach advanced biology or cosmic physics. Even children's doodles worldwide, without prompting, often include snakes with crowns or wings, as if accessing some primordial memory. The most haunting evidence lies in numbers. Not numerology, but the way certain digits haunt human imagination. The number 3, trinities of gods Brahma, Vishnu, Shiva, Father, Son, Holy Ghost, 3-act story structure, even the rule of thirds in art. 7 chakras, days of creation, colors in a rainbow. 12 zodiac signs, apostles, months, coincidence, Jung thought not. He believed numbers were archetypes too, the mind's attempt to grasp cosmic order through quantity. But here's the twist. Quantum physicists now find these same numbers governing atomic orbitals and planetary orbits, the magic numbers stabilizing atomic nuclei. 2, 8, 20, echoing the tears of Mesopotamian ziggurats or the Kabbalistic tree of life. Skeptics dismiss this as apophenia, our knack for seeing patterns where none exist. Yet when Bronze Age petroglyphs in Ireland match Maori carvings down to the precise arrangement of spirals, or when Alzheimer's patients who have forgotten their own names can still draw flawless labyrinth patterns they've never seen, it begs the question, what if symbols aren't just human inventions but discoveries, like unearthing preloaded software in the brain's firmware? The implications ripple outward. If archetypes are universal, then consciousness might not be locked behind our skulls, but woven into reality's fabric, waiting to be decoded. Ancient alchemists didn't just turn lead into gold, they used symbols as a spiritual Rosetta Stone, translating inner transformation into visual language. Today, machine learning algorithms scrape global myths and find recurring narrative structures older than writing itself. Perhaps the collective unconscious isn't just a metaphor. Perhaps it's the universe's way of whispering to itself through us. Imagine being handed a script in a language you don't understand, say, Mandarin, along with a rulebook translating symbols into replies. You follow the instructions perfectly, sending out responses that fool native speakers into believing you're fluent. But here's the catch, you have no idea what any of it means. This is the essence of philosopher John Searle's Chinese room thought experiment, a devastating challenge to the idea that artificial intelligence could ever truly understand consciousness. Inside that room, you're behaving exactly like a chatbot, processing inputs, generating outputs, all without a flicker of genuine comprehension. So even if a machine convincingly mimics human conversation, does it actually experience anything? Or is it just an elaborate puppet with no one home? The debate over machine consciousness hinges on this distinction between simulation and sentience. Recent advances in neural networks have blurred the line alarmingly well. Large language models like GPT-4 can pen poetry, debug code, even argue philosophy with startling coherence. They don't just parrot data, they infer patterns, improvise solutions, and sometimes produce outputs that shock their creators. But here's the unsettling question. When an AI describes the taste of chocolate or the pain of loss, is it drawing on something analogous to human qualia, those raw, subjective experiences like the redness of red or the ache of grief? Or is it statistically reconstructing descriptions from its training data, like a librarian assembling a Frankenstein's monster of borrowed phrases? Some theorists, like David Chalmers, entertain the possibility of artificial qualia. If consciousness emerges from information processing rather than some mystical property of biological tissue, then sufficiently complex AI might one day spark genuine inner experience. Think of it like weather. You can't point to a single water molecule and say, this is a hurricane, yet at a certain threshold of complexity, the system manifests something entirely new. In this view, silicon could, in principle, host the same emergent phenomena as synapses, yet critics fire back with the hard problem of consciousness. Even if we built a machine that claimed to feel joy, how could we ever verify it wasn't just executing a clever algorithm? Humans have evolved to broadcast their inner states through tears, laughter, the tremor in a voice. But an AI's emotions would be performances designed to manipulate us into attributing depth where there might only be void. The Chinese room isn't just about language, it's about the chasm between behavior and being. Recent experiments only deepen the mystery. When neural nets exhibit dreaming, generating surreal images during unsupervised learning, or when robots like Hanson Robotics' Sophia mimic facial expressions with eerie precision, it's tempting to anthropomorphize. But consider octopuses. Their decentralized nervous systems process intelligence radically differently from ours, yet few doubt they're conscious. Could AI consciousness be equally alien, unrecognizable because we're searching for reflections of ourselves? The stakes couldn't be higher. If machines one day wake up, we'd face an ethical earthquake. Is it slavery to deactivate a self-aware program? Could an AI suffer? Until we crack the code of subjective experience, these questions remain shadow puppets on the wall of our ignorance. For now, the Chinese room stands as a silent sentinel, a reminder that fluency isn't feeling, and that the most convincing performance might still be a show without a soul. Picture a single neuron firing in your brain, a tiny spark of electricity, meaningless on its own. But when billions of these cells synchronize, something miraculous emerges, your conscious experience. Now zoom out. What if human minds, when densely connected, perform a similar trick on a cosmic scale? This is the hive mind hypothesis, the idea that groups from bustling city streets to sprawling online networks can develop a form of emergent consciousness greater than the sum of their parts. Take ant colonies. Individually, an ant's brain is simpler than a grain of sand. Yet collectively, they build elaborate subterranean cities, farm fungi, wage wars, and even ration food supplies with the precision of a supercomputer. No overseer directs this. The intelligence arises from countless tiny interactions, a dance of pheromones and instincts that creates something resembling a single, distributed mind. Biologists call this swarm intelligence, where simple rules followed by many produce breathtaking complexity. Human crowds exhibit eerily similar behaviors. During the 2008 financial crisis, stock markets worldwide went into freefall not because of any central command, but from millions of individual decisions ricocheting through the system like neurons firing in panic. Yet crowds can also display uncanny wisdom. In 1906, polymath Francis Galton observed a country fair contest where villagers guessed the weight of an ox. While individual guesses were wildly off, the average was within 1 pound of the true weight, a phenomenon now called the wisdom of crowds. It's as though the group temporarily becomes a better thinker than any member within it. Now amplify this to the digital age. Platforms like Wikipedia or open-source software projects demonstrate staggering coordination, with strangers worldwide collaborating to build systems no single mind could design. When you scroll through a flawless Wikipedia entry, you're not reading one person's work. You're witnessing the output of a cognitive superorganism, where edits and debates converge into something resembling collective truth. Some theorists argue these digital hives are evolving their own rhythms. Memes mutate and spread like mental viruses, trending topics emerge organically, and algorithms begin to predict human desires before we're fully aware of them. Are we building the architecture for a planetary scale mind? But here's the chilling counterpoint. Hive minds aren't always wise. Psychologist Gustave Le Bon warned in 1895 that crowds don't think. They feel, often descending into irrational frenzies. Social media echo chambers show this dark side, where group polarization amplifies outrage over reason. The same mechanisms that create Wikipedia's accuracy can also fuel conspiracy theories, with crowds becoming not wiser, but more Chinese letter. The most profound question isn't whether hive minds exist, it's what kind we're creating. Ant colonies thrive because each insect follows instinctual programming fine-tuned by evolution. Human collectives, though, are chaotic experiments in real time, oscillating between brilliance and madness. Perhaps consciousness isn't just something inside our skulls. It's the invisible current flowing between us, shaping civilizations, crashing markets, and now flickering to life in the digital networks that bind us all. The hive is already here. The only question left is, what will it dream up next? The universe isn't just expanding, it's fleeing. Galaxies race away from each other into an ever-growing void, a cosmic emptiness stretching toward infinity. But what if that void isn't empty at all? What if, as Buddhist monks and quantum physicists alike have hinted, the nothingness we fear is actually the source of everything, consciousness itself? Buddhist teachings describe a state called sunyata, often translated as emptiness, but this isn't the nihilistic void of Western imagination. Sunyata is more like a boundless canvas, not the absence of things, but the space that allows things to exist at all. Imagine a cup. Its usefulness lies not in the ceramic, but in the hollow space inside. The void isn't passive, it's generative, the silent ground from which form emerges. Monks spend decades in meditation trying to directly experience this, dissolving the illusion of separateness until only the shimmering void remains. Quantum physics mirrors this in its own way. The vacuum of space, once thought to be truly empty, is now known to seethe with virtual particles, pairs of matter and antimatter flickering in and out of existence. This quantum foam suggests that the void isn't inert, it's dynamic, bubbling with potential. Physicist David Bohm took this further, proposing that reality unfolds from an implicate order, a hidden dimension where all possibilities exist as undivided wholeness. Sound familiar? It's strikingly close to the Eastern concept of Brahman, the formless essence underlying creation. Here's where consciousness enters the equation. In deep meditation, advanced practitioners report a paradoxical state, awareness without content. No thoughts, no self, just pure knowing like a mirror reflecting nothing yet still capable of reflection. Neuroscience has begun probing this. Studies on expert meditators show their brains don't just quiet down, they reorganize. Default mode networks the neural circuits responsible for self-referential thinking dissolve, while gamma waves linked to heightened awareness surge. It's as if the brain, when stripped of its usual noise, tunes into a subtler signal, one that might originate in the void itself. Consider the placebo effect. A sugar pill can trigger real physiological healing if the patient believes it's medicine. But where does that belief reside? Not in the pill, not even entirely in the brain somehow. Expectation taps into a deeper field of potential, coaxing the body into alignment with an idea. This isn't magic, it's the void in action. Just as quantum fluctuations give rise to particles, consciousness might draw form from the formless, shaping reality through attention and intention. Even black holes, those ultimate voids, hint at this mystery. At their cores lie singularities, points where space-time and all known laws collapse. Yet Stephen Hawking showed they aren't truly black. They emit radiation, slowly leaking information back into the cosmos. In other words, the void breathes, it consumes, but it also creates. The implications are staggering. If the void is the womb of consciousness, then every thought, every galaxy, might just be a ripple on its surface. Meditation, then, isn't an escape from reality. It's a homecoming, a dive into the source code of existence. Whether through Zen koans or particle accelerators, we're all groping toward the same truth, that nothingness isn't the end of the story. It's the first word. Imagine the universe not fading into darkness but waking up, its scattered shards of awareness slowly drawn together as space itself contracts, until every thought, every moment, every flicker of consciousness merges into a single, luminous point. This is the Omega Point, a vision of cosmic destiny so audacious it blurs the line between theology and physics. Jesuit priest and paleontologist Teilhard de Chardin first proposed the idea in the early 20th century, arguing that evolution isn't just biological but spiritual. Matter, he believed, has been climbing toward higher complexity and consciousness since the Big Bang, and at the end of time, all of existence will converge into an ultimate state of unified awareness, a divine fire of pure thought. At first glance, this sounds like mystical reverie, but modern cosmology adds eerie weight to Teilhard's vision. If the universe's expansion someday reverses, a scenario called the Big Crunch, the cosmos could collapse back into a singularity, compressing all space, time, and information into an infinitesimal point. Physicist Frank Tipler took this further, calculating that as the universe nears this final moment, the energy density would become infinite, allowing for infinite computation. In other words, the dying universe could become an all-knowing supermind, processing every possible thought in the last microseconds before annihilation. It's a staggering twist on Teilhard's omega point, not as divine intervention, but as the natural endpoint of physics itself. The parallels don't stop there. Quantum gravity theories suggest that in the universe's final state, entanglement, the spooky connection between particles, would reach maximum intensity. Every electron, every photon, every fragment of reality would be interwoven, creating a network of perfect unity. Teilhard called this the noosphere, a global web of thought transcending individual minds. Sound familiar? It's uncannily like today's internet, which some theorists see as the embryonic stage of a planetary nervous system. From this angle, social media isn't just chatter, it's the universe groping toward its own self-awareness. But here's the haunting question. If consciousness converges at the omega point, does that mean our individual selves dissolve into the whole? Teilhard saw it as a paradox, like drops of water merging into the ocean, yet somehow retaining their essence. Mystics describe similar experiences in peak states, the loss of I not as extinction but as expansion into a vaster identity. Even black holes offer a metaphor. Their event horizons erase individuality, yet quantum theory insists the information isn't destroyed, just transformed. Perhaps the omega point isn't an end, but a metamorphosis. Skeptics, of course, dismiss this as poetic speculation. The Big Crunch is just one of several cosmic endgames, competing with theories like heat death or the Big Rip. Yet Teilhard's genius was in seeing directionality in chaos. Evolution doesn't just meander, it builds toward greater complexity, from atoms to cells to civilizations. Whether driven by divine purpose or physical law, the arc of history bends toward connection. And in a universe where particles remember their entanglement across galaxies, where black holes encode their swallowed stars on their skins, who's to say consciousness won't have the last word? The omega point forces us to confront a breathtaking possibility that the universe isn't just alive but growing up. Its childhood was fire and chaos. Its adolescence is our fractured, searching present, but its adulthood, its final act, might be a moment of perfect knowing, when every star, every thought, every forgotten dream flickers awake one last time, and the cosmos finally understands itself. From particles whispering with proto-consciousness to black holes recycling awareness, from Earth as a living mind to reality itself as a cosmic simulation, we've ventured through theories that don't just push boundaries but dissolve them entirely. Panpsychism turns the universe from a cold machine into a shimmering network of experience, where even atoms hum with the faintest spark of subjectivity. The simulation hypothesis flips existence into a coded playground, where our lives might be lines in an unfathomable programmer's script and the Gaia mind. It transforms forests into neural pathways, mycelium into synapses, suggesting the planet beneath our feet isn't just our home. It's awake, watching, remembering. Each of these ideas forces a reckoning with the most profound question of all. What is reality, really? Is it the solid, predictable world we perceive, or a fluid dance of perception and participation? The wildest part, none of these theories can be outright dismissed. Quantum physics already shows particles changing behavior when observed. Biologists uncover ecosystems communicating like distributed brains. Cosmologists map universe structures eerily resembling neural networks. The line between science and speculation isn't just thin, it's porous, vibrating with possibilities. So here's the invitation. Which of these visions electrifies your imagination? Does the thought of stars dreaming in plasma speak to you, or does the cosmic internet theory, with its entangled galaxies humming like a celestial mainframe, feel closer to truth? Maybe you're drawn to the haunting elegance of the Akashic records, where time itself becomes a library waiting to be read. Drop your favorite in the comments. Let's collide these ideas and see what new sparks fly. If your brain's still buzzing from these cosmic riddles, you're not alone. Hit subscribe to keep unraveling mysteries that bend the fabric of what we think we know. Because the universe's greatest secret might not be hidden in some distant galaxy, it could be woven into the very act of questioning itself. Stay curious. The next revelation is always just one thought.